Search in video. While we consider stars, we presumably envision little sparkling things in the evening sky. Essentially, this is the way we see them from down here in the world, yet stars are something totally different. In truth, quite possibly the greatest star, Creepy Crawly Juice, is much larger than our sun. For quite a long time, this star has perplexed researchers. Yet as of late, another agitating component has been going on with Creepy Crawly Juice, making researchers and other well-informed people extremely concerned. Join us in this video as we investigate the breathtaking news about Betelgeuse, its looming obliteration as expected by the James Webb Telescope, and how this new advancement will affect our world and our lives here on Earth. As explained by physicist Michio Kaku, Betelgeuse is an enormous wonder, a huge star that has captivated cosmologists for so long. A Greek space expert named Tony was quick to discover it. This star is enormous to such an extent that it tends to be found in the night sky from Earth, especially during winter. Assuming you're into constellations, you've probably seen or heard of this star. It is the ruddy orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is old and, thus far, one of the brightest stars in the night sky. However, one thing about insect juice's brilliance is that it doesn't remain steady. Rather, it varies. This vacillation is one of the exceptional properties of this star, but it isn't the only one. Let's check out some of scarab juice's specific properties. A large portion of the stars you find in the evening sky are far from Earth. The closest star is 4.2 light-years away from Earth. If you fail to understand how the term light-years explain distance, picture it this way. Consider moving at the speed of light for an entire year. It's been proven that light can cover a distance of 186,000 miles per second. Consequently, the distance light can cover in a year is equivalent to 1 light year. If you do the math, you'll have billions of miles. So, when we say the nearest star is 4.2 light years away, it means it is billions of miles from Earth. Yet, think about this. Some stars are considerably farther, and insect juice is one of them. Insect juice is found roughly 600 light-years away from Earth. So if you were to travel to it at the speed of light, it would still require 600 years. We can't move that fast, not even our quickest rocket. However, this star can still shine so brightly in our sky. If you're wondering how scarab juice can be so bright despite its distance, that's because of its other characteristics like size and brilliance. Bug juice is multiple times bigger than our sun. Its radius is believed to be multiple times that of the sun. Unfortunately, it appears as a disk in space while using refined telescopes, whereas other stars appear as little points of light. The disk appearance is thought to be an effect of the reactions in the outer layers of its atmosphere. In terms of mass, insect juice measures around 12 to 19 solar masses. A solar mass is the standard unit of mass used by cosmologists. 1 solar mass is equivalent to 2 times 10 to the power of 30 kg. Researchers can't determine the exact mass of scarab juice because there are no other planetary bodies orbiting around it for comparison. Obviously, we can't measure it directly from here on Earth. However, it is estimated that this star is something like multiple times heavier than our sun. The brilliance of Creepy Crawly Juice goes from magnitude +0 to +1.6. In more familiar terms, scarab juice is multiple times more brilliant than our sun. No wonder it was nicknamed a red giant. However, the brightness of bug juice doesn't remain steady. It fluctuates. This variance is due to its pulsations. In other words, Creepy Crawly Juice expands and contracts. When it expands, it gets brighter, but when it contracts, it dims. This cycle can last for 10 to 100 days or even longer. One interesting property of scarab juice is that its surface is covered in dark magnetic spots. The magnetic field in these regions is far stronger than at the normal surface. Yet the downside is that these strong magnetic spots hinder the flow of hot gas to the star's outer surface, making the star cooler in these areas. The fact that bug juice has lots of these spots compared to our sun explains why it is cooler than our sun despite its size and brilliance. The sun also has its own dark magnetic spots, but those on bug juice are much larger and quite numerous. To give you an idea, the spots on scarab juice can be twice as large as Earth. Creepy Crawly Juice also boasts a magnetic field that is multiple times stronger than that of the sun. This field is the reason why, when seen through a telescope, the gases on the surface of bug juice appear to be in circles or arcs. Bug juice has a surface temperature of about 3,500 Kelvin. This low temperature adds to the low energy emitted by the star and its faint red color. Bug juice is a red star, but it wasn't always red. It was yellowish around 2 million years ago, much like our sun. Over the years, the color started changing to orange-red, and then around 2,000 years ago, it slowly started becoming the red star we know today. This fact has made researchers believe that the star is aging. Insect juice emits as much as 100,000 times more energy than the sun. It would have been a wild rival to Earth's sun if it weren't so far away. The fact that scarab juice, which is 600 light-years away, can still be seen with the unaided eye at night is quite surprising. Our sun is only 8.3 light-minutes away from Earth, which is why it's so powerful. If scarab juice were just slightly closer, we would also be able to see it during the day. However, if it were to replace the sun, it would engulf or displace the Earth and the other 4 planets close to it due to its colossal size. Moreover, even if it could fit, it emits more radiation than our sun. Bug juice, also known as scarab juice, is a very giant star located in the constellation Orion, roughly 600 light-years from Earth. This tremendous size is one of its most striking features. It is multiple times larger than our sun in terms of radius and could easily include the orbit of Jupiter if set at the center of our solar system. This giant size allows bug juice to appear as a distinct disk rather than a point of light when seen through powerful telescopes. Unlike most other stars, despite its massive size, insect juice isn't the most massive star. It ranges in mass from around 12 to multiple times that of our sun. This variability in mass estimation is due to the difficulties in accurately measuring the mass of stars that lack a companion star or other objects to provide gravitational reference points. Nonetheless, even at its lower estimated mass, scarab juice remains a huge celestial body. The brilliance of creepy-crawly juice is another vital characteristic. It shifts unpredictably over time, with its brightness ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is around 2.5 times brighter than a magnitude plus 1 star. At its brightest, creepy-crawly juice can be multiple times brighter than our sun. This variability is attributed to its pulsations, periodic expansions, and contractions caused by internal processes within the star. When bug juice expands, it becomes brighter. When it contracts, it dims. These pulsations can last for days to months, adding to its dynamic appearance in the night sky. Scarab juice's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct ruddy orange hue, typical of red giant stars approaching the end of their life cycle. Like other red giants, scarab juice is in the late stages of stellar evolution, where it has depleted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It displays dark magnetic spots on its surface, which are significantly larger and more numerous than those found on our sun. These spots are regions of intense magnetic activity that inhibit the flow of hot gases from deeper within the star to its surface, contributing to cooler areas on the star's surface. Scarab juice's history and cultural significance make it a notable celestial object. Known since ancient times, scarab juice has been observed and documented by various civilizations throughout history. Its visibility in the night sky, especially during winter in the northern hemisphere, has made it a prominent feature in constellations and mythology. Recently, creepy-crawly juice has garnered increased scientific attention due to its dimming episodes, which began around late 2019 and continued into mid-2021. During these periods, the star's brightness dropped to extraordinary levels, sparking speculation among astronomers about its imminent fate. Insect juice, also known by its formal name scarab juice, is a prominent star in the constellation Orion, located around 600 light-years from Earth. It stands out not just because of its position as one of the brightest stars in the night sky, but also because of its massive size and variability. This very giant star has dazzled cosmologists and skywatchers alike for centuries, offering insights into stellar evolution, immense distances, and the dynamic nature of the universe. Bug Juice is classified as a red supergiant star, which means it is in the late stages of its stellar evolution. In terms of size, Creepy Crawly Juice dwarfs our own sun. Its radius is estimated to be multiple times larger.